Dear students, this is going to be our 24th session on demonstration of S- uh, PSPP, and particularly the factor analysis that we had seen theoretically in the 23rd session uploaded. I hope you had gone through the 23rd session, because without 23rd session it's very difficult to understand the current session. So therefore I wish you would once again go through 23rd session, because the foundations for factor analysis are explained there. So after laying down that foundation, we can straight away move on to the demonstration. So what I would do, I would show you once again in our software called PSPP, a cloned version of SPSS. Here we can always find all our variable instructions or variable information mentioned in the variable view window. And then recollect these two windows. We will be regularly working with these two windows. So I'll always keep my variable view window open, because that's the place where I would know how my variables are laid out. Now here you can see that variable 12 onwards until variable 35, 12 to 35 are related to conflicts. So therefore, it's a 24 item conflicts scale. So therefore, we will operate, or we will conduct factor analysis on these 24 items. Now, as you know, the purpose of factor analysis is to reduce the data, large chunks of data, into smaller meaningful sets. So is there a way we can compress these 24 items into much smaller groups or much smaller factors? In other words, the purpose of factor analysis is also to find out what are the hidden factors or dimensions in these 24 items. So therefore, theoretically we all know that there are only three dimensions, namely work conflicts, family conflicts, and interrole conflicts. Now, whether these three dimensions are hidden, can we extract them, or there are more than three dimensions or lesser than three dimensions? So all possibilities can be found now in this analysis. So let's straight away move into analyze factor analysis. Now select your 24 items relating to conflicts, move them into from the list of variables to the processing box. Now this software is very simple. It gives you only two options. One is called extraction mode, and then the type of rotations. So if you click extraction, how to extract the factors. Now you can see here in the factor analysis extraction dialog box, there are, if you drop down the method of extraction, there are only two types. One is called principal component analysis and principal axis factoring analysis. We will be selecting PCA as per the yesterday's these instructions are discussions on factor analysis. And in after selecting principal component analysis, we will pick up correlated matrix, unrotated factor solution. We will also select scree plot. Now, as I told yesterday, eigenvalues should always be a minimum of 1. So less than 1, we reject those factors, and unless a factor having an eigenvalue 1 or more, we will accept it. Now, there is another option for extraction, is how many factors that you want to select. I'm not interested in theoretically defined factors, but I want naturally to know. The software should identify and tell me how many factors are there. Now, there is something called maximum iterations for convergence. This means how many times all these variables have to be rotated according to their axis. So I mean, by default it mentions 25 times, so I'll retain that and then click OK. and then we'll move on to the next option called rotations. Now, I've talked about some of these methods, not elaborately because they were very high and then not needed. Default Varimax rotation is what we talked about in the 23rd session. So we'll pick up Varimax rotation and just retain that maximum iterations and then continue. If you want to know about what is Varimax rotation, you can go back to our previous session. I'll also be trying to upload a PowerPoint file so that you could refer to the meaning of each of these, or you can even still go to Google and type out each of these words to know what actually are they. Now let's continue to see, and then we are ready with the instructions and we can straight away go ahead with running these instructions. So I'll say click OK just to see the output. Now I like this software particularly because of the way it generates the output. Much faster than any other software. Particularly SPSS also doesn't give me output that faster in spite of having much better memory modules. But this software is wonderful. It just gives me the output and I can save a lot of time. So now here you can see all your 24 items and their initial extraction. So each factor and its extraction value, which we call communalities. For example, this let us say item number 1 is having 0.57 communality. That means h square is 0.57, which means less than 1%. So likewise, if we keep on collecting all of them, we would know how much percentage all these 24 items would contribute to the formation of the factors. Like here, the next table will tell us the total variance explained. And this is a very interesting table. We will retain this table in case if we are analyzing this and presenting in our thesis or project reports. So this is the first table that we need to retain. And here you can see that total number of factors, the second column. This is the number of factors, first column. The second column is total number of factors. Now if you see factor number 1 and then eigenvalue, this is called eigenvalue, initial eigenvalue. Now the first factor has 4.7, which is more than 1, and it contributes to 19.6%. So this factor alone contributes to 19.6%. And if you see the second factor, as of now we don't know what are these factors, but gradually we have to know. So second factor which emerged is having eigenvalue of 1.64 and the percentage is 6.8. So alone it has contributed to 6.8%. So likewise, if you do, the cutoff mark is here. You can see ninth factor. So until ninth factor, you would find the eigenvalues more than 1. So in the previous discussions also I was referring to that. If an eigenvalue is having a minimum of 1, that is the real factor. If the eigenvalue is less than 1, these are all spurious factors. You can see from 10 to 24, each of them is having less than 1. So these factors will be discarded. We will not accept them. So what are the hidden number of factors? There are 9. Now let us see what is their h square. You can see that h square cumulatively put together is 62.7%. Likewise, if you see that here, totally it is 62.7%. This is what we will finalize. Sum of squared loading, that is the final result. So 62.7 is fair enough because all these factors put together, their h square, this is what we call h square communality, is more than 62 point, more than 50%. Therefore it's a fairly sound model, so we accept this extraction. So one clue I gave you here is, now in our 24 items there are 9 hidden factors. So all these 24 items will be distributed according to 9 hidden factors. Let us see how does it do. Now there are 9 factors having eigenvalues more than 1. In the graph, you could see how the eigenvalues are plotted here. This is only graphical pictorial presentation of eigenvalues. So you can see here, these are eigenvalues, and you can see the eigenvalues are starting from 9. You can see from here. So factor 1 is having above 1.5, that means somewhere around 4. And then similarly, as it comes to, you can see eigenvalue 1, that's the cutoff. So ninth factor. So totally 9 factors are having eigenvalues more than 1. The scree plot is only graphical representation of the eigenvalues presented in total variance explained table. So doesn't matter. So let's move on now. Now in component matrix, you would only see the correlation between variables and the latent variables. Now we are using that word. These are called observed variables and these are called latent variables. Latent means hidden. These 9 dimensions are hidden in 24 items. What are they? As of now, we don't know, but it's just to show the relationships. But as we move into the next table, we will have more clarity. Now, this is what we call rotated matrix, rotated component matrix after rotation, and this is before rotation. So after rotation, you would know how each of these 24 items is related to these components. Remember the bicycle wheel I was referring to? In the bicycle wheel, suppose when the spokes get broken, they join together to some of the other spokes and they form a bundle of spokes. That's the same analogy applied here. These 24 items rotate inside your computer memory and they get hooked to these factors from 1 to 9. So for example, you can see the first item at work, I have things that should be done differently, got hooked to the fourth factor. So you can see why is it? It's because the fourth factor is having 0.71. So the first item yielded a value of 0.71 with the fourth factor. But if you see with the other factors, it is very, very meager. Now, what are these factors? We have to know that. I'm sorry. What are these values? 0.71, 0.64, 0.04. What are these values? By now, I think you could have guessed. Those are called factor loadings. So somewhere you can also note down these values are called factor loadings. This is my final table that would go into my project report in the interpretation section. So what I will do now, carefully I will identify how many items correspondingly belonging to each of these 9 factors. So you can see first item belongs to fourth factor, second item also belongs to fourth one. uh, yeah, but there's a confusion here. The second item is also belonging to first factor. Now, as I told in the previous discussion, your factor loading, which is like your correlation coefficient, should have a minimum value of 0.40. Then only that observed variable belongs to a particular latent variable, which is also called factor. So for example, at work, I am not able to be myself yielded 0.43 to first factor, 0.60 to another factor. So this could be because of the number of rotations that we have limited. For example, we have taken maximum iterations 25. If we increase beyond 25, probably it might reduce. This value might reduce and get attached to the fourth component because the fourth factor is little stronger. So assuming that second item also belongs to this factor output, I'll give some name like that, output. Now I'm saving that output. I hope it's got saved. Yeah, it's open. So now you can see this is what we call CSV file. Excel sheet will open CSV file, so I'll straight away open that. Now you can see all my values are intact. So this is what my last table. So my last table is the rotated component matrix. So What I'll do, I'll slightly expand it. Now this is the way it looks, and then I can still see some incompatibility issues while exporting PSPP output file into CSV format. So this question, what is it? So we can fine tune them later on, we can clean them up. So but what we'll do now, we'll just select things like this. I hope I'm doing it right. I'm not comfortable with Excel much, but I keep exploring. So let's try sort it. Here it would ask me what to sort out. Sort by, let me try one, largest to the smallest. Now I can see these three questions belong to first factor. So what I can do, I will select like this, create a new file or extend a worksheet, then separate them like this. Now likewise I'll go back. Now, in the second one I'll try that. Column C, largest to the smallest. So now I would know these are the items and these are the values. So I'll copy them, paste them beneath, or I'll separate by one row. And instead of copying them here, I'll copy them here. So that's my second one. This is only for segregation or clear presentation. Now we are trying with column D. So as I told you, your factor loadings could be only more than 0.4. So these are my values, only two items. So keep on trying like this. Yeah, for fourth factor, we have only three items. And for the fifth item, somebody might suggest a shortcut method also, but this is how I'm doing it. This is how I've learned it. Remember, when you're working on computers, you must know how to do it much faster to save the time, because computers steal a lot of our time, which is very, very precious. I think this is the way we have to keep on trying. There's no other method, I guess. In case if there's a better method, anybody could suggest me, I'm willing to learn. Probably this software should help us next time in sorting it out separately for each factor and give us the output. Probably some of us can write mails to the programmer suggesting this method is laborious. So you can see for the seventh item, for seventh factor, only one item is loaded. Yes, something went wrong. Sixth one, yeah, this is the sixth one. Fifth one, this is the sixth one, and this is the seventh one. I'm sure we are concluding now. So column I. So only two items for column I. Sorry. And then I move on to the last one, the ninth factor. So three items are loaded on ninth factor. So that's it. I come to the end of my output. So these are the items and these are the factor loadings. I can even put h square here. Subscript, I don't know how to put. Superscript. Will it work? No, it doesn't work. So I'll simply say h square or communality, and I'll copy the percentages of each factor here. So this is how I would do that. That's it. So make a tabular form. So now I'll convert that into Excel sheet for consistency and compatibility. And then what I'll do, I'll shrink them so that to make it properly laid out for your project report A4 size page. So it looks good, and I'll take this particular table into my final output. So copy that, then open it in some Word. I think I have already opened. So I'll copy it here. So that's how my final output would look like. So it's almost now done fairly. The only thing is you have to identify what are the names of these factors. That's the toughest part in factor analysis. Of course, most of the thing is done by the software itself, but labeling or giving names to these values is the most toughest type. For example, theoretically, we've identified that there are three dimensions of conflicts, namely work conflict, family conflict, and internal conflict. Whereas here you can see there are more than three factors. So totally nine factors are there. So what could be the reason? So sorry about the way we have paused. What we will do here, instead of presenting h square here, I'll remove it. I'll delete it. 62.70%, and I'll move on to the end of the sheet, end of the table here. I'll then enter a new row, another row, and here I'll type communalities h square, and then here eigen values. So I'll go back to my output, Excel sheet output, and from here I'll copy those values. Yeah, the eigen values are here, so copy that. Then you can, for time being, you copy them in a transposed, then copy that, move it into your MS Word. So here we can type your eigen values. That's it. Done. So now communalities. How would I copy communalities? These are cumulative, these are individual, so I need individual scores. Again, I'll transpose them. Transposing is rows into columns, columns into rows. So I will copy my communalities here. Done. So I can even put another total is 67 point something, 67.62.7. That's the total percentage. So I can put it here. That's it. My table is ready. My final output is ready. Now only one more is missing. I'll save this file. CS factor analysis table. I'll give a name later on for convenience. Much better one. No, but now here the only exercise that is left out, which is the toughest of all in factor analysis, is giving names to each of these factors. Now you might be wondering how it can be, how to give these labels. Now one clue is check through your factor loadings. Now for the first factor, these are the three factors, sorry, observed variables or items. Now these three items are heavily loading on first factor. So what you should do is now try to understand what is the content of these three items. So you can say, my spouse and I have different ideas about spending time with relatives. My spouse and I differed about spending time alone. So it's all about spending time. So it's all about at work I am not able to be myself. So it's all about time issue. Uh, so spouse, time, here also time, and here also at work I'm not able to be myself. That means here also it's innately time. So we can give a label called time conflict. It may be people might differ with it. There can be some other also, but nearest I thought, according to my understanding, these three items are talking about time related conflict. Or it can be there is a spouse issue and there is also self issue. So SPOUSE, spouse self conflict. We can give a new name like this. So I'm just giving an example for only factor 1. We can try for factor 2 to factor 9, but that's the same process. I'll just try with second factor and discontinue the topic. Now for the second factor, let us see how many items are heavily loaded. So there are 4 items, 5 items I guess. Yeah, 5 items. So 5 questions belong to the second factor. So what does it mean? On the job, I have so much to work to do that it takes away from my personal interests. So job is occupying more of his life. Then my job, it is also job. My work, it is also work related. So as you move, because of my work, so it is also work related. But except the last item called my family forced me to do things I rather not do. So because of the family, he is more involved in the work. So it's all about work related. All these 5 items are reflecting on work related incompatibility. So what I'll do, I'll simply type work conflict. That's it. So this is the way we have to give labels. This is the only toughest part in factor analysis. Even the best of the best academicians struggle to give these names. Of course, for students it should be much more difficult, but I'm sure this generation is much smarter. So with the kind of education that they have, with the kind of technology that they were born with, I think they can make out things much better than our generation. So I think with that I come to the end of factor analysis, and I hope you have understood all the way the steps that are involved in doing factor analysis, the theory wise, the demonstration wise, and I'm sure you will also try this method on your data because you're also doing things in real time. So therefore, I wish you all the best once again, and then happy enjoying, happy working on this software, and then marshal over it, become masters of it, because you're the generation who's getting into data analytic careers. So this is going to be your foundation. Once you are through with this software, using it, you might get familiarized with the brand new softwares that are much more powerful, more stronger, give you more model building, model testing, and so on. So I wish you all the best. With that, we come to the end of Unit 4, and tomorrow I'm going to upload Unit 5. That's going to be my last session for the season. So I hope this lockdown situation had helped you to learn research methods more meaningful, more focused, much better than the traditional format. In case if you still have any doubts, clarifications, in case if you want me to upload any more videos, I would rather do that cheerfully. So let me know. Until then, I wish you all the best.